that later. So I'm going to keep this on. I think I need to turn this down so we don't have shouty bits. My phone. Meeting. Hey. There's the third meeting. Whoop. Now I think that should give me audio off my phone and not cause the world to scream. Okay. And I want to, I should probably, okay. So when you load that, it yells at you, right? So can somebody suggest, so the errors down at the bottom says your code contains at least one syntax error, meaning it is not legal Jython. The error is on line 3. Can anybody suggest what is incorrect here? Joseph has the look of somebody who might have an idea. Oh, Jaden's got an idea. Bingo, full marks to you, sir. It's indentation. So the body of the for loop has to be indented, and you have it lined up exactly the same as the for loop. So your line 3, intensity equals, starts at the same position as the for, FOR right above it, and that can't happen. So you need to indent that. You probably need to indent another 2, yeah. So whenever there's a colon at the end of a line, so this would be def, this would be for, there's a thing called a while loop, which we haven't seen, but it does it, an if, an elif, an else, all of those have a colon at the end of them. So the code below them needs to be indented for at least as many lines as you want to have in the block that is connected to whatever that line above is. So here, lines 2 through 5 are the body of the definition. So they all need to be indented in from the def, and they are. Lines 3, 4, and 5 are all part of the for loop. They need to be indented in from the for, and now they are. But the fact that they weren't before is what was causing it to yell at you. It was unhappy because the line right below the for line, line number 2, was at the same indentation level as line 2. And it was like, whoa, no, no, no. You had a colon at the end of line 2. I'm expecting at least one indented line, and there weren't any. And so I'm all grumpy, grumpy, grumpy. Okay. So if you save and load that, hopefully it will not yell at you. Hey, it did not yell at you. So that took care of that problem. So indentation, it does matter. Welcome to Jeff. Well, welcome to Python. That's a Python thing, not a Jeff thing. So, is that cool? Other question. No question too small. Joseph. Right? Yeah, yeah. Go ahead and share if you're willing. Right, but you can share your Canvas window and show us what's happening if you're up to that. And I was a silly person, and I had paused the recording before we started to try to limit the amount of dead space at the beginning, and then I forgot to unpause it through the entirety of Sophie's question. So all of that stuff about right picture two, none of that's in the video. I did make another video that goes through right picture two separately that I posted over the weekend. So there is a video that talks about that, but the particular stuff with Sophie, none of that's actually going to be in the video. I was a silly person. The Yubo's question will be in the video. I sort of noticed it right after we finished up with Sophie's picture. So you should always feel free to be like, "Are you recording?" Because I think you can see the recording thing up at the top, and if it's not there, you might be like, "Hey, you, record, please." Okay, so Joseph's about to share. Okay, so go to the discussion, share picture. Yep, that's the thing. So then in that reply box there, yeah, just in there, start typing, yep, boop, and that thing comes up. And then if there's a picture, it's like if you go up to the little icons right above the text, no, right above the text, there's a bunch of icons to the right, stop, that one there. So if you click that, it'll ask you to find an image. Now, this is actually not entirely obvious what to do here because it gives you three options. A URL, that would work if your image was on the internet somewhere on a web page, which it probably isn't. That's probably not going to work. Flickr on the far right would work if you happen to have a Flickr account and you've uploaded your picture to Flickr, but most of you probably haven't done that, so that's not a good choice. So the thing to do is actually Canvas, the one in the middle. So click Canvas. Now, at this point, it's like, hey, you don't really have any pictures on Canvas. So you'll need to take your picture and put it on Canvas, and then it will become available. So if you click on My Files, would be what I would recommend. Now this upload file has become available. So you could click Upload File, and then go find your picture. And I don't know where your picture is, so Merry Christmas on fishing that up. Sure. And then scroll down so we can see the rest of the, oh, actually maybe you can't scroll. Oh, seriously? Oh, so I guess, you can see the rest of this dialogue where there's like a save button or something farther down that we're not able to see? Oh, there we go, yeah. So you can provide alt text if you want. So on the web, not everybody can see the pages, right? Some people are visually handicapped and can't see at all or have very poor vision. And many of these people will use what are called screen readers that will actually read web pages out loud to them. And there's a problem then if you come across a picture, what does the screen reader say? Other than there's a picture here. Like it can't describe the picture magically. So alt text is a way for you to say, this is what's in this picture, so that if somebody is viewing the web page through a screen reader, they can get a description of the image. So, you could say 2 children playing checkers, right? If that's what the picture's of, right? And then the screen reader would say, there is a picture of 2 children playing checkers. And then the person who is listening to the page would have some idea what was there, as opposed to there's some random picture. I don't know what to say about it. Now, in this class, I don't have any reason to believe anybody is visually impaired. And since a significant part of the class is manipulating images, which would be certainly an interesting experience if you were visually impaired, I'm not overly concerned about you doing anything with the alt text, but I wanted to explain why it was there. So if you want to just leave it as JapaneseGate.jpg, that's fine by me. If you click the decorative image box, which I would not do, because this is not a decorative image, it's an important part of the content of the post, then a screen reader will actually not say anything about it. So if the picture is not part of the content of the page, then the screen reader will ignore it. And then if you wish to change its size, you can in the dimensions. Those will default to the actual size of the picture, 800 pixels by 533 pixels. But you could say, oh, I want it to be 400 pixels wide, so it's not as big. You could change that here. When everything looks good, hit the update button. And lo and behold, there's your picture. And then you can put text around it and paste in code and do all the stuff. But that uploading a picture is actually not super obvious in Canvas. So, questions about that? Do I need to do another example of that? People good? Other questions? Good questions. Happy campers. Ask a question. I would love for you to ask a question. That would be awesome. So far, no questions. Any questions, or should we move on to, so the thing I would probably do next, what time is it? Yeah, is actually talk about how to actually assemble the collage some and do an example of what that might look like. But if there are other questions, I am totally here to answer questions. Okay, so I'm going to do two things. I'm going to first show a picture and not explain how I did it, but tell you that how I did it is the examples there. So if you want to look, see, I want to share this. So you should be looking at my Canvas folder, pictures from Nick, and I did some playing around. This is the original image, and I really like the sort of strong blue sky there. And I posted an example on turning the clouds pinky purple. So essentially, I went into Explorer and tried to figure out what was true about the pixels in the clouds, and in particular that were different than the white in the building. And essentially, it was not quite as bright as the building and had a little red in. And so then I wrote a little desk program that took those pixels and added, increased the amount of red and decreased the green slightly, and you get that. And I did a lot of fiddling to get the amounts right. And you can see it's not perfect. There are sections of the cloud that are still unpinkified. And there are bits of the building that got turned pink. So these windows here got pinkified. There's a little spot right here that got pinkified. But in general, it did a pretty good job. I got sort of nice pinky clouds. and it was fun to play with. So that example is um, uh, up on Canvas if you want to have a look at that. But what I'm going to do instead is focus now on like how to actually do collagey kind of stuff, how to combine multiple pictures into a single image. But does anybody want to ask me questions about this quick before we like dash on to that? So basically, I just go through all the pixels, and if they have the right red and blue values, then I add some red and subtract some green. And that gave me this nice picture. Okay. So what we're going to shoot for today, and I don't think we'll get the whole thing, but I'll show it to you. This is the whole collage that I generated. And so I did several things here, and we won't have time to talk about all of them, but we can talk about sort of the new ones. So the first thing I did is I did the Pinky Clouds bit, which we just saw. This is the Japanese gate. So that was the picture that Joseph just uploaded. And what I did there is the sky on the Japanese gate is a really strong, even blue. So I used the chroma key example from chapter 5, I think. So chroma key, you assume you've got sort of a uniform color background, and then you replace all the bright green pixels, if it's a bright green background, with pixels from another image. And this is how weather people can walk in front of weather maps. They're actually standing in front of a brightly colored background, and a computer somewhere is replacing that background with the weather map, and that's how they can wander around in front of it. And so I've done the same thing here. I use the fact that the Japanese gate picture has a super clear blue sky. There are no clouds. It is just this really strong blue, and there's no other blue in the picture. The gate doesn't have any blue in it. The forest at the bottom doesn't have any blue in it. And I basically said, replace all the blue pixels with pixels from this other picture with the pink cloud. And that lets me insert that new picture into the Japanese gate picture. But it keeps the gate, and it keeps the forest, and the little temple over here is still there because it wasn't the bright blue. So we keep the sort of the structure of the original gate picture, and we replace all the sky parts with the other image. Okay. And that's in the example that we'll talk about, but I'm not going to go over that right now because I want to get into the how do we stack things together. So then I stacked that with, this is the sepia tree version of the tree that I think we did in class. And then this is another picture which I haven't modified at all. That was just taken here in town a year ago, I think, a year and a half ago, over on the other side of town at night. And so I just plopped it on there. Okay. And the collage assignment wants you to have 4 images, at least one of which has got grayscale on it. And so this is actually a combination of 4 images. There's the image with the pink clouds, there's the Japanese gate, there's the sepia, and there's the Park Avenue at night. And some of them are just kind of plopped in there, and some of them I did something fancy with. Okay? But this would, and I'm sort of cheating a little bit because you're supposed to use grayscale on one of them, and I didn't use just a pure grayscale, but sepia starts by doing grayscale and then fiddling it some. So I decided I'd count that because I like the sepia picture. I figured I'd cheat a little. I'm teaching the class. I'll do what I want. Okay, sorry. So I want to talk about how to stack things. How do we take 2 pictures and put one on top of the other? And then if there's time, we'll talk about how to plot the Park Avenue picture on the bottom right as well. Okay, that's the goal. Questions? Okay, let's do this thing. Stop sharing. Start Jeff, which is still version 5. I've got to fuss at them again. They need to update this for me. Come on, Jess, you can do it. Okay, share screen. Yeah. Okay. So, I'm going to write a function stack that takes two pictures. Let's just write some comments here. Takes two pictures, top and bottom, and generates a new larger picture that has top at the top and bottom at the bottom. Okay. So I'm going to take two pictures and stack them one on top of the other, and makes a new picture. I'm not modifying an existing picture. And one way to tell that is the new picture is going to be bigger than either of the original pictures, right? If I've got a picture that's 300 pixels tall and a picture that's 200 pixels tall, I need the resulting picture to be 500 pixels tall. And I can't get that by modifying either of the existing pictures. I'm going to have to make a new picture. Okay? Does that make sense? Do we sort of get what stack is trying to do? Okay. Now, first thing I'm going to do is I'm going to figure out how big everything is so I can figure out how big the resulting picture is going to be. So top height, I'm going to say is get height top. So get height is a built-in function in Jest that takes a picture and returns how many pixels tall that picture is. Okay. So that's a nice Jest tool that makes it easier to manipulate images. And I can say bottom height equals get height bottom. Okay. And I can say width. Now let me stop sharing this and let's share the whiteboard for a hot sec. Because I want to draw. So, come here, pen, thank you. So, why are we on something weird? No, so I've got two pictures. I've got top, and that looks more like Iowa than a rectangle, but you know, hey, let's count. And I've got bottom. So I've got these two pictures, and I want to put them together to make one new picture. And a picture has to be a rectangle. So this is going to have to ultimately be, in this example, something like that is going to have to be the resulting shape. Because we can't have like a little notch out of the top like Utah. It's going to have to be a rectangle. Okay? And so if come here. If this is YT and this is, let's not say Y, let's say 8. This is H of T, and this is H of B, then the total height of the resulting image is what? If I know the top one is, say, 200 tall, and the bottom was 300 tall, what's the height of the whole thing going to have to be? Yeah, it's just the sum of the two heights, okay? So this is like word problems from middle school, which you have repressed because, you know, who wants to do word problems from middle school? But here we are doing word problems for middle school. So the height of the whole thing is h of t plus h of b. You want the height of the top plus the height of the bottom. That'll give us the height of the overall thing. Okay? Now, what about if this is width of top and this is width of bottom? What's the width of the overall thing in general? Like in this example, WB was bigger than WT, but we don't know that that will always be true. So what's the width of the resulting picture going to be in terms of the width of the two inputs? Anybody? Well, if the top one's 300 wide and the bottom one's 400 wide, well, what's the width of the picture going to be? The combined picture going to be? You can do it. Darren, you look confused. Ask a question. So if the top is 300 wide and the bottom is 400 wide, how wide does the green resulting picture need to be able to hold them both? Yeah. Why 400 versus 300? Bingo. So in general, if WT is the width of the top picture and WB is the width of the bottom picture, what's the width of the resulting picture going to be? Well, we don't know that either of them is 400. The key thing is why did you choose 400 over 300? Say that again. Yeah, it's bigger. So you're gonna the width of the resulting picture is always the bigger of the two widths. We don't have to know what the widths are. We just know that whichever one is larger, that's what the width of the resulting image needs to be. So the overall width needs to be max, and there's a built-in thing in Python, max, that does exactly this. So the width of the resulting picture is the larger of the two widths. Okay? Does that make sense? Questions about that? And so that's what we're doing first in the Python code, is figuring out these widths and heights so that we can create a new image that has the desired size that we can put these other two pictures into, copy these other two pictures into. So we're essentially going to create a empty image. So we're going to choose an empty image. So we're going to make an empty image that's the right size. And then we're going to copy the pixels from the top image into the right place in the new picture, and then copy the pixels from the bottom image into the correct place in the new image. So we'll copy all these pixels over, and that'll give us the desired combination image. Okay? And this will be two separate for loops. So we'll have a for pixel in get pixels bottom, and we're going to have a for pixel in get pixels top. So there's going to be 2 for loops, one to do the first set and one to do the second set. Okay? Are there questions about that before we try to do it? Going. Anybody at home? Got a question? Good? Okay. Stop sharing. Go back to Jess. Share. Jess. Share. So the height, I'll call it stack height, is top height plus bottom height, right? We did that little bit of math. And then the stack width is going to be the max of get width top, get width bottom. Okay? So that has given me the size of the resulting picture. My resulting stack needs to be stack height tall and stack width wide. Are you with me on that? Questions? Now, we have to make an empty picture to put stuff in. And there is a function called make empty picture for exactly this purpose. So result will be make empty picture. And empty picture takes width, height, and an optional color. So you can see maybe at the bottom, it's telling me that make empty picture takes width, height, and then color is in square brackets. If Jess tells you something in square brackets like that, it's saying that's optional. You can provide a color, but you don't have to. If you don't provide a color, it will use white for all of the pixels in the picture. If you provide a color, it will fill that picture with that color. Okay? So we can fill it with whatever color we want, or we can leave it alone. I'm just going to leave it alone. So stack width and stack height. Boom. And then we need to return the result. Now, that's too early. We haven't done all the copying, but this will give us sort of a starting point. So, and then we have do the for loop. Okay. So, are there questions about this structure? We're figuring out how big the picture needs to be. We're creating an empty picture of that size. We'll have to do some stuff, and then we're going to return that. Are we cool with this? Questions? Going? Okay. So then the for loop. For pixel in get pixels top color let me think. Okay, so what time is it? Make sure I'm keeping track of where we are. 10:07. Okay, so we can get the color of the pixel, and now what we want to do is set color for some pixel color. Problem is we don't know what pixel to set it for. That needs to be a pixel in result somewhere, but we don't know where in result to put that, okay? And if we think about our little picture from earlier, the top picture just goes in the upper left-hand corner of the result. So the X and Y coordinates of pixels in the top picture are the same in the original image and in the target image. So here we could say X is get X pixel and Y is get Y pixel. So get X and get Y are just functions, again, that are built in for us and tell us where a pixel is located in an image. What row is it on? 0 at the top and counting down. And what column is it on? 0 on the left and counting to the right. Okay, so this tells us where that pixel came from. And now I want to get the pixel in the result image at that location. So I can say target pixel equals get pixel. Oops. And if you look at the bottom again, down here, it says get pixel picture, xpos and ypos. So if we hand get pixel a picture and an x and y coordinate, it gives us the pixel at that location. So we can say result xy, that gives us the target pixel in the result image. And now if I say target pixel here, I've essentially extracted the color from the top image, found out where the top image was, found the corresponding pixel in the result image, and set its color to be the color we got out of the top picture. So that will copy all the color, all the pixels from the top image into the target image. Okay. That was a lot. Questions? Oops, that one up. Desktop. One. Okay. Questions about all that? Now, if I load this puppy up, ooh, it loaded. I sort of figured there'd be a mistake. We haven't copied the bottom picture yet, but given the time, I want to actually see that this works. So stack takes two pictures, so I need to get a pair of pictures. Let's say gate is make picture, pick a file. So I'll choose desktop. Oh, yeah, okay. Actually, I don't have the gate on here. So we will choose the tree. And so actually, gate's a terrible name. And then we'll say B is make picture, pick a file, and we'll just get one out of the media sources folder. Doodly doodly doodly. We'll do the garden one. Garden ESC. Garden. There we go. Okay. So we got two pictures. Let's look at them to make sure that they look okay. Yeah, that's right. I'm not going to flip over because we'll be here forever, but I just checking quick. Show B. Yep. Okay. So these work. Now let's actually try stacking them, which will be incorrect, but we'll get there. So I want to say S is stack gate onto B. Whoa, yelled at me. What did I do wrong? The simple typo. I can't spell. Somebody save me. What's broken here? Pixels needs to be plural. Control S, load again. Try stacking one more time. Hey, yes. There isn't a function called get pixel without an S. Oh, there is. Sorry, yes, right here. So get pixels takes an image and gives you all of the pixels as a great big group. And you usually then go through them with a for loop. Get pixel singular takes a picture and an X and a Y and gives you one pixel. The pixel in this picture at that location. Does that make sense? So yes, good question. And if we show, let me share the picture we got. So this is our resulting picture. So we've got the tree, which I called gate because I was dumb. And then this is the blank space where the other picture would go, where the garden picture would have gone. if we copied it over. We haven't copied it over, so it's just a big blank space right now. But we'll copy it over in a hot second, and then we'll have the whole thing. Okay. Questions about the setup here before I dash through quickly? Okay, so then let's share Jess again and try to wrap this up fast. So now we have to do copy the bottom picture for pixel in get pixels plural bottom color equals get pixel or get color pixel x equals get x pixel y equals get y pixel target pixel equals get pixel result. Now we can't just use x and y here, because if we do, we'll be putting this picture up at the top on top of the other picture that we already copied in. X will stay the same, but y needs to be y plus top height. We want to push all the pixels in the bottom picture down top height rows. That's how far we want to shove all that stuff down so that those pixels go lower in the image, okay? So when y is 0, this will be top height, will be right at the bottom of the top picture, and as y gets bigger, we'll move down rows from there. And so then we'll set color, target pixel, color, and that should take care of us. We load, and we do this again. Show S, share, share, share. Lo and behold, we managed to successfully stack two pictures on top of each other. And notice that the garden picture was a little narrower than the tree picture. So it got the width correct and just left us with a strip of white where the garden picture doesn't quite go all the way across, because white was the background color. And we can do with that as we see fit. We can leave it alone, or we could fill it with another color, or we could plop another picture on the bottom right and cover that up, whatever makes us happy. But this allows us to take two pictures and stick them together in a collage style. This is only 2. For the assignment, you need to do 4, but this is the right idea, okay? And the tricky part, perhaps, is getting the math about the location sorted out. So you do have to think a little bit, and I almost always end up drawing on paper to sort out what the locations of everybody are, and make sure I get the offsets right, because it's hard for me to do that in my head. Questions? That was pretty fast. Let me go back to Jeff. Questions about that? So we computed the dimensions and made the new image. That's all that stuff. Then we copied, so I should change this comment to copy over the top picture. We copied the top picture across, and then we copied the bottom picture across. And when we did the bottom picture, we had to add top height to all the y coordinates to push that down. If we wanted, say, to have the pictures be horizontally aligned instead of vertically aligned, we would add to the x coordinate to push the second picture over to the right, okay? And if we wanted it to be, say, in the bottom right corner, we'd have to add both to the x and the y to push it down into that corner. So it depends on sort of where we want it in the image as to what we have to do to it. Okay. And there's lots of examples in the book of this kind of stuff as well. Okay, so questions? Sun looks mostly. Get a picture posted tonight, if at all possible. If you are having trouble with that, let me know ASAP. It's really, really important, or we're not going to be able to make progress. Then start thinking, if you haven't thought about what your collage might look like, you should think about what your collage might look like. What images do you want to put together to make the collage, and start thinking about how you would do that, okay? My code for making my collage is all on Canvas, so you can look at all of that. I'll actually post my collage to the collage assignment, hopefully today, hopefully this morning, if I get home and don't get jumped by some pile of to-dos that I've forgotten about. And so it'll all be there, and you can see the original images and the code that made the whole collage, in case that's useful. But you should definitely be thinking about what your collage might look like and how you can make it work. And, you know, I'm here to help. So if you get to a place and you're stuck, definitely let me know. Email, Canvas, asking class, making an appointment. Most of the appointment slots tomorrow are still available. And so I will try to help out. So, questions about anything in the 0 minutes that are remaining? Go team Ra. We will make this happen. Awesome. Stop sharing. End meeting. Everybody good at home? Coolio. Thank you. See everybody later. Ciao. End meeting for